Alright, continuing on with the notes from section 2.1, solving systems of two equations, two unknowns. Next we'll have inconsistent systems. Those are systems that have no solution. Oops, let me grab my pen. Systems that have no solution, they will be called inconsistent, and that means that if you graphed them, the lines don't intersect, so they'd have parallel lines with the different y-intercepts. They'd be two separate lines, just like that. Make this a little darker. Okay. Alright, so let's see what it looks like. We're not going to graph these. We're going to solve these either by substitution or elimination. So let's try to solve this system for this example. Alright, 3x minus 7y equals 20, and negative 6x plus 4y is equal to 15. I'm going to use elimination. And with elimination, I like my x's out here. If I multiply the first one by 2, then I'll have a 6x there. Alright, and let's bring the second equation over. Alright, so you see those coefficients to the x's match. I've got a positive 6x and a negative 6x, so when I add, those cancel, but look what happens to the y's. Negative 14y plus 14y, everything canceled over there. What do I have over here? 55. Alright, 0 equals 55. That makes no sense whatsoever. So there is no solution to this equation. Or you can say it's the empty set. And the original system is inconsistent. There's no solution to an inconsistent system. It's just like a regular equation. If when you're trying to solve it and your variables cancel themselves out, and then you end up with 0 equals 55, for example. Alright, just like that. It's the exact same thing here, but we started with a system. Two equations, two unknowns. Here I tried to use elimination, but what happened is that we just eliminated all the variables, and I have two numbers that are not equal to each other. So let's look at the converse of this. What if when I try to solve this system and I end up with like 6 equals 6, right? That's going to be infinitely many solutions. If you graphed it, it'd be the exact same line, right? You graph the first equation, looks like that. Graph the second equation, it's right on top of it. Right, they're the exact same line, but we're not going to do this graphically. Let's look at this system here. 8x plus 10y equals 18, and then 20x plus 25y equals 45. I'm not sure what I'm going to do to this. To try to match these coefficients, but be opposites, doesn't matter. It doesn't matter. You know, you could gross these up. I could multiply this one by a 2 and this one by a negative 5. That would work fine. But I'm going to approach this a little differently. Watch. I want these first coefficients to be 4s. And I can do that because if I divide the second one by 5, I wouldn't have any fractions down there. And if I divide the first one by 2, I won't have any fractions there. So watch what I'm going to do. Let's say divide by 2. Or multiply by a half. It's the exact same thing. Okay, watch what I get. I'm going to get a 4x plus 5y is equal to 9. And then, okay, so I got a positive 4x there. I want to get a negative 4x down below, down here. So here I'm going to divide by negative 5. So it's going to change the signs. So I have 20x divided by negative 5 is negative 4x. 25y divided by negative 5 will be negative 5y. 45 divided by negative 5 is negative 9. Right, the only thing I was trying to match with the opposites are those x's there. You totally don't have to divide if you don't want to. I like to keep my numbers smaller if possible. You could totally use the 50s here if you wanted, which maybe most people would do, or 40s up front doesn't matter. Okay, what happens? On the left-hand side, everything cancels because we've got 0. On the right, same thing. Alright, so when that happens, there are going to be infinitely many solutions. But let's see how we're going to write that. Right, for infinitely many solutions. The relationship between the two, you can get it right from the equation 4x plus 5y equals 9. So, depending upon what your x value is, your y is going to depend on what x is. So let's solve this for y and see what happens. Negative 4x plus 9y. Negative 4/5 x plus 9/5. Alright, you can pick your x arbitrary. That's where the infinitely many solutions comes in. X can be any real number whatsoever. But, you know, your y just can't be anything. Y is going to depend upon what x is, and it'll look like this. Negative 4/5 x plus 9/5. Or, you know, you can have negative 4x plus 9, the whole thing over 5. It's the same thing. Sorry, 5. Alright, I'm not sure how WebAssign is going to want you to enter those answers, and it might just be, I don't know if they're going to want an ordered pair, but that's how you'd do it. They might just say, you know, tell me if there's infinitely many solutions or if there's no solution. Or if it's, yeah. Alright, just like that. You could get this exact same thing as if you solved this for y, you're going to get the exact same thing. Or if you solve the second one for y, you'll get the exact same thing. X is arbitrary. Choose any x whatsoever. Then plug that same x in there and you'll get the ordered pair. One of those answers. Alright. Let's look at this application of equilibrium points. I have enough room. I think I have enough room. Alright, yeah, application of the systems of equations, a very common application. This has to deal with supply and demand in economics. First of all, an equilibrium point, that's the point where supply equals demand. And in econ, when you talk about supply and demand, they have very simple, I'm sure they could be more complex than this, but you always start off with really simple linear equations. Right? Your supply curve should always be positive sloping, and that demand curve should be a negative sloping line, and the equilibrium point is right here in the middle. Alright, so here, find the equilibrium point. Okay, they already give you the models. P here is the price and X is the unit volume. Alright, the number of units produced. P is the price. Produced or sold. Okay, for supply, they give you this for the price, and for for demand was the first one, supply is this one. Alright, to find the equilibrium point, we need to solve this system. I need a P, this is going to be my X, and this is my price over here, P. I need a particular X value and P value that's going to satisfy both of those, so I need to solve this system. Now look, they're both solved for P, so the easiest thing to do, set the two things equal to each other. Alright, that's substitution. Take all of this and put it right there, so you set the two equal to each other. So that's negative 18x plus 970 is equal to 15x plus 640. Okay, solving this one, let's go ahead and add the 18x. And I'll get a 3x over here. Oops, I'm sorry, yeah, 33, my bad. Plus the 640. Alright, and now, if you subtract the 640, how much is that? 330. Well, that's nice. Alright, your x is going to be 10. Right, your x should equal 10, and I'll put it in order pair in a minute. So x equals 10. Once you get that, plug it into either one of those. It doesn't matter to solve for your p. Plug it in the second one. $150 plus 640 should give me 790 for p. Again, you can leave them separate or write them as an ordered pair, 10 and 790. Again, 10, that's the, these are 10 widgets. Alright, that's the volume. And then this is a price, so a $sign on that. Right, this is your answer. Right, so that's equilibrium. I think you have an applied problem, something similar to this, and deals with equilibrium. It's an economics topic. So that takes you through all of 2.1.